Okay, this is Charles Sterling from Sterling Power Products. One of the things we get continually asked about is why do we put on our lithium batteries that you must use a battery-to-battery charger in order to current limit the power going into the battery and also prevent your alternator from overheating. Well, what I'm going to do is a quick test down in the test bench down below, and basically what we're going to do is it's a 90 amp Bosch onto one of the lithium batteries, just one off. Remember, you could have 3 or 4 of these, and we'll load up the test bench as well. So really what I want to show is the temperature that an alternator will go to when you start putting the maximum current through the alternator, which is what a lithium battery will do. Lithium batteries have a good thing, which is they charge fast, and they've got a bad thing, is they charge fast. So what's good about it will also destroy everything around it. It will destroy your alternator. So the point we're trying to make is that if the lithium battery is left to its own devices, you can put it directly on an alternator. But when you see what it does to that alternator when you overload, well, overload's the wrong term, you max out the alternator, you will see that at that sort of temperature, bear in mind downstairs is probably 15 to 20 degrees, where your engine room or your boat engine's probably about 100, 120, 150 degrees before you start. So at the top of an engine room, etc., you could add another 100 degrees easily onto the readings that we're going to show you, and the readings we get here will be horrific enough. So this is really why we say to people, don't run your alternator flat out, especially with lithium batteries, because they're absolutely brutal and they will rip the guts out of your alternator. It won't necessarily burn the windings, but you could certainly lose your diodes, you could lose the solder on the diodes, and just generally the alternator will fail. So don't be under any illusion that you can run an alternator for 3 or 4 hours at full power and not have a downside to it. Also on top of that, alternators cool down depending on the speed they do. They've got the fan on the front that cools the alternator down. There's a sort of sweet spot for that fan. Go too slow with maximum current, your alternator will get hotter. Run faster and you're fine. So there's lots of factors to take into account. Hopefully at the end of this, the bottom line is don't run your bloody alternator at full power or full speed, or full power should I say, because you're just going to burn it out, and then there's no point complaining that you weren't told this. So everywhere you look, everywhere you read, everybody you talk to with any brains will tell you try and keep your alternator down below 80%. Now bear in mind, we're working with Bosch on this alternator here. So we expect fairly good readings, but there are a lot of alternators out there. You would have smoke coming out of the alternator by the time we finish with it. Okay, so we'll go downstairs now and run through some of the tests and show you what's going to happen. What we're doing here is a quick test on alternator power versus temperature. So what I've got here is a lithium battery connected to a load on the test bench here, and we're running a Bosch 90 amp alternator. So the first thing what we're going to do is let's pull the full load out of the alternator. So I've got this loaded up. I've got an amp counter here, and we are doing at the moment 99.6 amps. Bear in mind this is a 90 amp alternator. So what's the temperature like at the moment? So we'll switch this on. We'll do temperature here. So you can see inside the coils here we're at 150 degrees centigrade. The outside case isn't so bad. So we'll keep running this for a little bit longer and we'll see how this changes. So that's been running now for about 3 minutes. Let's try again. I can really feel the heat coming off that now. Okay, that's about another minute, 4 minutes. So we're at 165 on the windings. The alternator is doing 97 amps. So what I'm going to do now is turn the RPM down until the current starts to drop off. So we'll put this on here. So now at 95 amps, so let's reduce the speed until we start to lose the current. So this is the sort of danger thing where you're getting full current but at low speed. And this is where the alternators really start to heat up. So we're now at 92 amps. Starting to drop off the current. I can feel the heat coming off this thing badly. So let's see where we are now. So simply by reducing the RPM, this could be a tick over. We're still doing about 92 amps. Let's see where we are now. So in that short period of time, oh, I've lost it. So we're going from 160 odd to 184, and that's just by dropping the RPM of the alternator. So now the fan isn't turning so quick, the alternator is not getting cool so much, and this is where you start burning things out. Now what I'm going to do now, I know that battery there is probably about 3/4 full. I'll get it on the app, just hang on a sec. Okay, you can see here that that lithium battery's just under 3/4 full. We're only putting 12 amps into it, even though we're producing 100 amps there, 90 odd amps. Most of it is going into the load on the machine. So what I'm going to do now is turn the load off the machine, so all the current is going to go into this battery. Okay, there's no load on the machine now, and you can see here there's 91 amps going into the battery, and we're producing 91 amps here. So what this is showing is that lithium batteries, remember that's one battery, you could have 4 or 5 of these. Lithium batteries, the good thing about them is they charge fast. The bad thing about them is they charge fast. So this is how, I mean I can smell this alternator now, this is how you burn out alternators with lithium batteries. This is absolutely brutal, and this will keep going at full current on that 90 amp alternator. Now that's a Bosch alternator, so from marks out of 10, that's a 10 out of 10 alternator. So it'll cope quite well with this, and certainly in this environment I wouldn't expect that to burn out. But then there's different definitions of burnout. A lot of people think burnout means you're burning the coil. Burnout could mean you're destroying the diodes. Burnout could mean the solder that's got the windings connected to the diodes could melt. It's unlikely the actual windings in this alternator will burn out, but you can really smell it. So let's go and check the temperatures again. So there we are now, 199 amps, and we're still climbing. So it just shows you that this will probably go up to about 220 amps. But bear in mind, this is a nice room. This is probably at about 18 degrees. That alternator could be in a vehicle at the top of the engine where the engine's already at 100 degrees plus. So you could be another 100 degrees on top of that, which brings you up to 300 degrees. And it's all these combination of factors that, as they say, burns out alternators. But the main thing to note here is that that little battery, 100 amp battery lithium, is holding, which is 3/4 full, is holding that alternator flat out. Now, that battery will hold that alternator flat out for 1 hour. If you had 4 of those batteries, that alternator would be 4 hours in a hot engine room. That's when you start getting really serious problems, and that's why you need battery-to-battery chargers to reduce the output of that alternator down to about 70 or 80 amps, which it will sit at all day. But you know, you can't smell this, but I can smell this from here now. Hang on. So we're at 183. I suspect this battery's backing off a bit. Yeah, we're down to 77 amps. So this battery is backing off. As I say, we were already pretty full. So yeah, you can see here, we're 75% full nearly, and the current in the battery's dropped down to 76 amps. Now, had we put that voltage up to 14.4 volts, bear in mind that's just a standard regulator, 14 volts, that would have stayed at 100 amps all the way around there. So to give you a full test, that battery's too full to, you know, show you everything. But you did see the 90 odd amps going in there. You saw the alternator going to 200 degrees, and these are the things that we're you know, trying to warn you about. So what I'm going to do now is artificially load the alternator back up to 100 degrees to see how much hotter it'll get. Okay, so we're loaded to 90 amps, well 88.9. Again, bear in mind, when you first fire the alternator up and it's cold, you'll probably get about 110 amps. But when the alternator warms up, it'll go to 90. So we're back now to 88.6. It won't do any more than that. Where's the gun? So that's still at 187 there at the hot spots. So just to show you the difference, what I'm going to do now is increase the speed of the alternator. That's all I'm doing is the speed. I'll just check this for a second, hang on. Right, we've got up to 95 amps by increasing the speed, but that won't make much difference. What I'm trying to show here is what the temperature does by increasing the speed. Oh. So within 30-40 seconds, we've already dropped nearly 30 degrees in temperature just by increasing the speed. So you can see how critical it is not to run alternators at full current at a bad RPM. This will probably come down a bit more. Let's just stay to that. So hopefully we've shown you a couple of things. One is how brutal lithium batteries are, that they will keep pulling the power, maximize out your alternator. Second thing is, if the alternator is running too slow and the fan has not got a chance to work correctly, the alternator will get hotter. And the third thing is that the alternator will just be at full power all the time. Now you've seen the temperatures going up around the 200 degrees, add 100 onto that into an engine room, and you're at 300 degrees. Solder will melt at about 200 If it's lead, if it's tin, it's about 350. So you can see how things will start falling apart very quickly. As I say, that's a Bosch alternator, so that wasn't going to go on fire or smoke. But believe you me, there are alternators like Eastern European ones. Certainly the Japanese, the German and the American alternators would not fail under these circumstances, but certainly Eastern European, Indian, something like that there, I would be expecting to see smoke appearing. So hopefully we've shown you enough there to realise why you need battery-to-battery chargers, why you need to current limit the output of the alternator, because it can't keep that up all day. I would put money on if that was going to fail, it would be the diode pack fail, not the windings. But you can smell it in the air, you can smell it's not a happy bunny. So just let that run a few seconds to sort of get the residual heat out of it. But we might show you something else later, but hopefully you've seen enough there to show you what the problem is. Thanks. I'll switch that off there, and just out of curiosity, bear in mind this is bear in mind that's just been switched off. The internal windings are still at 160 degrees, and now the case is way up to 120 degrees now. So you mean, because there's no air going through it, that's just going to get hotter for a little while with the residual heat. Okay, we'll show you more on these lithium batteries later. I mean, as I said, the good thing about lithium is they charge fast. The bad thing about lithium is they charge fast. So in order to not damage your systems, use battery-to-battery chargers to reduce the output of the alternator to stop it doing what you can see going on here. All right, thanks then.